Hey there, I'm Chloe. I'm going to be giving a talk on Go unit testing today. This is a talk that is based off of a blog post that I wrote on Go unit testing at Compass. So it was about Go unit testing in general, as well as the specific strategies that we use at Compass. So I want to start off with a question. And that question is, how do you ensure that your team is producing high quality code? So this question kind of comes from the fact that, first of all, I think it's a question that all engineers are always wondering is, how can I make sure that the code that I'm producing is high quality? Another reason that this comes to mind is because at Compass, one of our principles is quality first. So we try to make sure that whatever we're producing is effective as well as high quality. And the way that we do this at Compass is a mix of unit tests as well as integration tests, end-to-end tests, code coverage, and also just trying to do thorough code reviews, etc. But more so, I asked this question because I'm curious what other people's experiences are with this. I'm just always looking for new ideas, and I just think it's always an interesting discussion topic. So I just wanted to start with that. So what I'm going to be talking about today, I'm going to start with an introduction about who I am and why I, decided to write this blog post. Talk about the basics of unit testing as well as the basics of unit testing in Go. And then I'm going to talk about Testify, which is a library that we use to enhance our testing tools at Compass, and talk about the separation of concerns principle and why that helps a lot with mocking in unit testing, and tie it all together with a big example, basically. So first up, I'm Chloé Powell. I'm a senior software engineer at Compass. I've been there for about 1.5 years. Before that, I was at a small DC startup and have been working in the DC tech scene for 4.5 years. My day-to-day, I'm a tech lead for one of our teams at Compass, which focuses on automating day-to-day agent activities, specifically relating to communication with their clients. So nurturing them, sending follow-up emails, checking in, etc. And then finally, I just wanted to mention that we're hiring. So I included a link here in the slides. I also included my LinkedIn if anyone wants to ask me any questions about working at Compass. But we are always looking for new people, and we're hiring for all kinds of different positions. So feel free to take a look. So just wanted to start with the basics of unit testing. So the general goal of the unit test is to assert that one piece of logic does what it's intended to do. And it's important with unit tests that we focus on one small piece of logic. So most of the time in a code base, you'll have a bunch of different kinds of tests, and unit tests should really have the narrowest scope. And another thing I wanted to mention was typically with unit tests, we're going to be comparing an actual value against an expected value. So when we talk about actual values, that's the actual output of actually running the piece of logic that we're testing. And we want to compare that output against what we think should be the result in the conditions that we are running it. And then finally, as I mentioned before, unit tests are really best as part of a larger testing suite. And at Compass, as I mentioned before, we couple unit testing with other kinds of testing like integration testing and end-to-end testing, which really focuses more so on making sure that all the pieces of a system work together properly rather than a small piece of logic, which is what we care about with unit testing. So Go unit testing. So specifically when we're talking about unit testing in Go, normally the first thing that comes up is the standard testing package testing. And most of the libraries that people use to test in Go will be built off of the standard package. And so basically I wanted to talk about the basics of using that package, totally separate from libraries. So first of all, the package is designed so that you can just run the command go test with the path to a test suite, and all the tests in that test suite will be run. So when I say test suite, I'm actually talking about a file that ends in _ test.go, and it will have a bunch of test functions in it. We'll talk about what actually a Go test function is in the next slide. But for example, with test suites, like if you had a file called like library.go, and that had a bunch of functionality relating to a library in it, you would also probably have a library _ test.go, and that would be the test suite for that file. So inside of a test suite, you'll find a bunch of test functions, which are basically just tests. And test functions are just regular Go functions, but they have some rules, which basically make them tests. And I've listed them here. The first one is that the signature of the test function is of the format func uppercase test, uppercase word. So that's like test library, or test whatever. And the following, the second most important thing is that the first and only parameter of that function is of type testing.t. And then finally, any functions that are test functions need to include, or we want to use methods of type t in them. So for example, most of the time these will be like if statements, and then inside of the if statements we'll return t.error, and that will basically be the way that we'll signal to the system that there's been a problem and that the unit test did not pass. So it's always easier to explain these kinds of things with examples. So here I have an example of a method called sub. Really straightforward, takes in 2 parameters and returns the first one subtracted, the second one subtracted from the first one. In this example, I'm going to be testing it using the standard testing library, right? So we have a test called test sub. We have an actual value and an expected value. So given x being 6 and y being 3, the expected value would be 3. 6 minus 3 = 3. So now we want to actually compare the expected value against the actual value, which we get by actually calling the method. And then inside this test, you can see if actual does not equal expected, we want to t.fail, and otherwise it's a success. So another thing that we have at our disposal with Go unit testing is test tables. These are really useful because we can set inputs and outputs as a slice of structs, and run the test multiple times with these different values. And it's also really useful for reducing code duplication, because you can imagine if we have like 5 tests, but they're actually all doing practically the same thing with different inputs and outputs, we're writing that test 5 times instead of just writing it once and trying it 5 different ways. So it's really useful for just code reduction, but it's also really useful for being able to add new test cases easily. And that's always something we want, because we want it to be as easy as possible for people to add unit tests. So you can see here in this example, this is a test table. So we have our inputs and our outputs defined as a slice of structs. And if you look at var subtests, I'm actually defining 6, 2, and 4, where 6 is x, 2 is y, and then 6 minus 2 is 4. So 4 is my expected value. And I'm also going to include a little message in there so that if one of them fails, we want to make sure we know which one it is. So you can see here, I actually am only writing the test once, because it's getting the actual, which is actually running the sub method, and it's comparing them, but it's doing that 4 different times. And this is really useful because you can see here, I've actually changed the sub method a little so that there are actually 3 different cases now. So if X is greater than Y, we're going to do stuff one way. If Y is greater than X, we're going to do stuff a different way. And then if neither of those cases are the situation, we're going to return 0. So there are 3 test cases here that I could technically have written as 3 different tests, but why do that when they're all doing the same thing? So you can kind of see the benefit of using a test table. So next up, I want to talk about Testify. This is a link. If you want to read anything more about it, feel free to go into the slide and click around. But Testify is a library that we use at Compass. Different teams use different libraries, but my team uses Testify for all our unit testing. And basically, this just is a library that allows us to have more options for unit testing. So 3 ways that this does this that are really useful for us is through the assert package, which offers us a whole bunch more, a whole bunch of really easy ways to assert that things are happening properly. So I'll include some examples of that in the next slide, I believe. Next, there's mocking. So Testify has a mock package, which provides us with methods that make mock stubbing really easy, which is something I'll talk about later as well. And then finally, test suites. I don't go into this in this talk, but this is another thing that Testify offers us, and we actually use it at Compass. And what's really useful about test suites is that you can define a setup and a teardown method that will just automatically run before every single test within the test suite. And yeah, who knows, maybe I'll do a follow-up blog post or talk on that specifically. But anyway, so let's talk about assertions. So Testify offers us this assert package. If you go in, you can see all kinds of options. These are just a few that we use all the time in our tests. And it basically just makes checking that the actual, you don't need to specifically check that the actual matches the expected. You want to check certain characteristics about the actual and the expected, right? So you might want to make sure that if something happens, some other thing is not null. Or you might want to make sure that the Boolean response is true. And I'm going to explain another benefit of that in a second with an example. But one of the other things that's really nice is that rather than having a whole bunch of if statements in our tests, we can just do one of these statements, which essentially is an if, right? So like assert.equal, that's basically if actual not equals expected, then t.error. But instead, we're just doing assert.equal. So it's just one line. So the next thing I wanted to say was that the error messages are a lot more verbose. And I have an example of that later as well. But you can imagine when using something like assert.true, that's telling the system something that's a lot more specific than there's a failure, right? Like there's a failure is not very specific. I can see that there's a failure, but I'm gonna have to dig into what exactly happened. With assert.true, we're gonna know, no, this wasn't true. That's a lot easier for us to figure out. So here's our test table from before. I know we already looked at it, so we won't hover on it too long, but you can see there's this if actual not equals expected, then t.fail. In comparison, this is using the assert library or assert package of Testify library, and you can see assert.equal, it actually just goes ahead and compares all those things. And so we're cutting down on our if statements. The other thing was, as I mentioned before, with the verbose messages, this is the example where the test fails earlier. So the original test that I showed you with the test tables, that one fails. Okay, it failed, but that doesn't really tell us a lot. Now I'm gonna have to go and look at the code, see what it's actually doing, try to figure out why it might have failed or what the failure even is. In comparison, this is what happens when the test fails when it's built using the assert package. So rather than just saying it failed, it says it failed because the expected value is 2 and the actual value is 3. And this happened at line 12. So, it just provides us with a lot more information, which makes debugging a lot easier. And really, I mean, the goal of a unit test is to make it so that we can try to figure out what's wrong if something does go wrong. So this is a really important benefit of this library. Next up, I want to talk about separation of concerns principle, which is basically the principle that you should test layers independently and write code organized into independent layers that represent the flow of data through the system. So I'm going to follow this up with an example that kind of clarifies this, but basically when we're writing tests that are testing unit tests that are testing pieces of logic within a complicated system, we want to make sure that we're testing that logic independently of other things that could be going wrong. So let's say we're testing one layer of an application that uses 3 other layers. Those 3 layers should be controlled. They shouldn't potentially have something wrong as well. And we want to make sure that we can do that. And the separation of concerns principle basically helps us to build our code in a way that makes it easy to test by really isolating the pieces of logic that we're trying to test. The goal is that we want to be able to mock everything except the layer that we're actually testing. And I often talk about this as like a controlled experiment. So you want to control all the variables in the experiment so you know what happens when something goes wrong. If the other layers that you're relying on also could be breaking, that's not really informative. So that's kind of the way that I like to explain this. So here I have an example. Let's say we're building a service that's like a library service. The main goal being that users can check out a book as long as the book's not currently checked out. So you can imagine there's the server layer or the controller. This is where the requests get routed through. Next up, we have like the business logic layer. So in this case, let's call it the library API. This is actually doing like the logic of the request. And then finally, we have a data layer. So let's say we store the books in a database. So you can imagine the server layer or controller gets the request, routes it to the right method of the library API layer, and then the library API layer uses the data layer to fetch the book and make sure that it's available for checking out, and then allow the user to check it out. So here we've defined the library API interface. So you can see I built the interface so that the library DB, as I mentioned, which is the data layer, is a dependency of the library API interface. And the reason that we do this is so that we can potentially pass a mocked version of the database or the library DB layer rather than passing the actual library DB layer. And this is a great way to control the experiment that we're going to run. So you can see here I defined the library DB interface, right? So it has a struct, which is DB book. It has a checked out by user ID string, and it has 2 methods, which will get the book from the database or check out the book from the database, which essentially will just set that checkout by user ID string field. And then here we have a method called checkout book, right? So this is a method of the library API. And what it'll do is get the book from the database using the layer that we defined, the injected DB layer. And if the checkout by user ID field is not equal to null, we'll throw an error and we'll say, sorry, this book is already checked out. Otherwise, we want to check it out. So you can see both in the first line where you get the book and then the last line where you check out the book, we're making requests to the database layer that we passed in when creating the interface. So now we're going to talk about mocking. And we'll just go back to that example in a little. So the goal of mocking is to test each layer of an application without also testing the components that they rely on. That's what I was mentioning before about the controlled experiment. So we want to basically pass a fake controlled version of each of the layers that aren't the layer that we're trying to test. And this makes it so that other things won't happen. I have a typo here, but basically a mock is something that meets all the requirements of the interface. It is mocking, so it can stand in the place of that interface during a test run. So basically, the ideal scenario is that you can inject a mocked version of an interface instead of injecting the actual version, which could, have all kinds of things going on that we don't want to deal with. Like, we don't actually want to establish the connection to the database. We don't, that could actually create other problems. There could be a failure because the connection failed, etc. So we want to mock it and then just pass a fake controlled version of the database to the API layer so we can just focus on the API logic. And then finally, I included some mock generation tools. I'm not going to go into too much detail here, but this is basically, we use both of these at Compass, but I'm going to include an example of one that was generated by Mockery. And this basically just generates the mock based on an interface that you've defined. And then finally, you want to stub out methods to ensure that the mock is working as you expect it to. So basically, you create a mock, you generate it from an interface, and then you're going to pass that in when you instantiate the object that you're going to test. And then within the test, you want to define how the mock is going to work. So you want to say API or library API is going to ask for a book. Respond with this. Library API is going to hit the checkout book by whatever method. Respond with this. And that is useful for a number of reasons. One, it makes it so that we can control what's going on and actually have it return the right things. And then two, it actually ensures that the right requests are being made to the mock. So if the library API makes a request to get book with a different ID than what we expected by when we started out the mock, it will error. And so that's also a good way to ensure that the library API in this example is acting properly, but also that it's passing the right information to the mock to begin with. So here's an example of a generated mock. It's not really worth going into too much detail, but basically this is a mocked interface. It's going to return what I told it to return based on the parameters that I told it to expect. And then here's an example of actually using this. So you can see in the example to the left, we're actually injecting the mocked DB layer when we're creating the library API that we're going to test. So we're creating a real library API interface or implementation, but we're going to pass the DB mock instead of the library DB, like the actual one. And then on the right, we're going to set all the values on that mock and tell it how to act. So we're going to say, library API should call getBook with the parameter book ID. And if it does that, I want to return checked out book, which is a book that has no checked out by user ID field. So I'm setting up the test to return a book that has nothing in that field, which means that the API logic should then check out the book. So following up on that, I then stub out the checkout book method, and I say, library API should request checkout book with two parameters, one being book ID and one being user ID. If this happens, return null, which means there's no problem. And then I'm literally running the actual method, and that is the way that we get the actual value. So in this case, error is the actual value. And then after that, we want to confirm that error is nil. So we want to make sure that that error is empty. And this is the way that we basically ensure that A, the library API method is interacting with the library DB properly, and B, if library DB returns the things that we've set it up to return, library API actually checks out the book. And then this is just an example of if, let's say I had stubbed this out incorrectly and I had set up the get book mock stub to expect user ID instead of book ID. You can see that the test will actually error and say, this is weird. You told me to expect user ID or user one when get book is called, but I'm actually seeing book one when get book is called. And that's another good way to make sure that your logic is interacting with the mocked layer properly. So basically, that was the full example. I just wanted to kind of go over the main takeaways here. So for me, the main takeaways are isolate logic. You want to make sure that you're controlling everything else so that you can really target the piece of logic that you're trying to test. And you can do that by using mocked interfaces. So mocked interfaces are really great because you can control all the layers that your piece of logic is interacting with so that you can make sure that none of the failures are ever going to be in another layer. And that's why you want to use interfaces so that you can actually do this mocking. Testing libraries, there are all kinds out there. They're not necessary, but I find them really useful for just essentially enhancing the tools that you have for testing. We want to make unit testing as easy as possible so that everyone will write a whole bunch of unit tests. That's really the goal. And I think that testing is one of the things that people can kind of get lazy about and not want to do so much of. So if you're using a library that makes it really easy, that just really benefits your whole team. And then, as I mentioned before, controlling all external variables. That's really important because we just want to make sure that we know that if something's going wrong, it's in the logic we're testing. So ultimately, just harping on the same thing I've said numerous times through this talk, unit tests are most powerful when they're the most targeted component of a larger testing strategy. So it's really important to have all kinds of different testing to make sure that unit testing is doing its job, but that we're also making sure that all the systems are being tested properly. That's all I have. Thank you for listening to this talk. Definitely, if you want to reach out to me about applying to Compass, please do so. Talk about how you like to ensure that you're producing high quality code, please do so. And I hope you all have a great day.